Okay, let's go ahead and get started. So welcome to class. So this is EDLD 653, Functional Programming in R. So I just want to give a sort of little bit of a sort of set the expectation for this class a little bit, okay? This class, I think, is pretty inarguably the most difficult course in the sequence in terms of programming. Okay, so machine learning might be harder in stats, and the first class is hard because everything is brand new. But this class, we go into the weeds on the programming of things. Okay, so that means it's going to be difficult. Okay, unless you have a lot of programming background, it's going to be hard. Okay, so expect that going into it, that things aren't always going to make sense, and you're not really always going to know why things are acting the way that they are, or when to use one sort of loop versus a different kind of loop, or how to improve the function that you've written to make it better, or whatever, right? So, so recognize that from the start. This is, I think, the most difficult course in the sequence in terms of programming. Okay, and so as you go through, you're probably going to experience some discomfort, and that's okay, and that's normal, and it's expected. Okay, so that's just my first little spiel. Today, I want to basically get on the same page, talk about the syllabus, and then we're going to talk about data types in R. Okay, data types in any programming language are very important. R has 4 primary data types, all of which you've used in the past, but we're going to dig into them a little bit deeper. Okay. Before we do that, I think pretty much all of us know each other, but it would be great if we could just spend a couple of minutes introducing ourselves anyway. So we'll go around the room, and then we'll go onto Zoom. So yeah, it's been a little while since we've all been together now too. Some of us a little bit longer than just the week off. So tell us why you're taking this class, and then something fun that you've done outside of class, you know, if not over spring break, at least sometime recently, okay? And then what pronouns would you like us to use for this class? Okay, so I'm Daniel. I am teaching this class rather than taking this class, so that's a little different. But one fun thing I did, I took my family up to Great Wolf Lodge over spring break, and we spent 3 nights there playing in the giant pools and slides and stuff. So that was super fun. And my pronouns are he, him. Okay. Thank you all. So this term for me, I think most of you know this, but a few of you may not. I accepted a new position with a company called Able. And so I am starting full-time with them next week. So this is officially my last week at UO. However, as part of my transition, I negotiated with Able to allow me to teach this one last class before I fully leave. So at the end of this week, all of the rest of my full-time duties are gone, and I will be working full-time for Able, but I'm also going to be teaching this class. So that means a few things, right? It doesn't mean that I'm less committed to you, right? I'm still going to be here for you. I'm still going to be able to help you, and I'm still very committed to helping you learn. That's why I'm here at all, right? Like, I didn't have to stay to teach this class, but I really wanted to for 2 reasons. A, for the department, but really more for you all, so that you have the opportunity to take the course, because it wouldn't have been offered otherwise, right? So so be rest assured that I am still here and very much committed to you. However, it also means that time is going to be very tricky, okay? I have the time that I'm teaching the class, and then I have time on Friday afternoons, okay? So in the syllabus, I just updated it today, I have said that office hours are going to be Friday from 2 to 5 p.m. Okay. And so if you need to meet with me, ideally it will be sometime in that window. And so just email me and we'll figure out a time and we'll meet via Zoom. Okay. If we need to meet at a different time, it's probably going to have to be either in the evenings or on the weekend, which is no fun for anybody. But that might just be what we have to do. Okay. All right. So any questions about that part of it before or anything? Okay. So moving on to the syllabus, if my slides will advance. Okay. So we have a course website, just like we had last term. It is very similar in terms of the look and feel of it. It's just got a dark theme this time instead of a light theme. Okay, so it's FP for functional programming -2022.netlify.app. Okay, and this is linked on Canvas, etc. So when we're here, this is just the homepage, right? But you can go to the schedule and you can see all of the topics across the weeks. One of the things that you will notice that is very different this time compared to previous times is the slides are already posted for just about every week. The only weeks that are left hanging are 8 and 9. Week 10 is actually Memorial Day, so we will not have class that week. So we actually only have a 9-week term rather than a 10-week term, okay? So 8 and 9 are not posted. I'm going to post them this week though, but I have gone through all of these. It's not like I just slap them together and put them up there. I've gone through them just like I would every term, and I have revised them to update them. And before, you know, it was always, we had it twice a week instead of once a week. So I've combined across them and everything. So my hope is moving into next week where I'm working full time for Able, that I won't have to do much course prep because it's already there. Okay. Similarly, if we go to assignments, all of the labs are already posted. Okay. You will have a midterm quiz, which we'll talk about in a little bit, and a take-home midterm that is also already posted. Okay. So theoretically, you could get started on any of this at any time if you want to. Okay. So you could work ahead if you feel like it. Okay. But otherwise, this is basically the same as before. We do again have a class repo. And this is where everything that this builds the website, right? So this has everything that you will need for the course. So just like last course, I would recommend, and I think this is linked in Canvas, but I can make sure here in a second. But just like last time, I would really recommend that you clone this repo and then just poll every week for updates, okay? Because I've built out the course so far for like most of the term, the updates won't be as frequent as they were last term, but you might still, I will probably still be updating small things each week, so it's probably still worth polling each week. Okay. For the course, there are a set of learning objectives. And these are all fairly general, but I think they'll make more sense as we get going. So understand, be able to describe the differences in R's data structures. That's what we're starting with today. And when each is most appropriate for a given task. So we have atomic vectors and list vectors. And so those are really different. So understanding when to use an atomic vector versus a list is going to be a big thing. That's kind of what I mean for appropriate for a given task. And then of the data types, it's going to be more obvious. Do you want it to be a string, or do you want it to be a number? If it's a number, is it an integer, or is it a floating point, which is called double in R, etc. Okay. We will also focus pretty heavily on the per family of functions. So the per library. We will actually start with all the base R looping variants, and then we'll move to per. And hopefully my hope with that process is that you see the sort of base looping mechanisms, and then how those are generalized in per, and why per is often preferable. Okay, not always, but often it is preferable. Okay. We're also going to be working with what are called list columns in data sets quite a bit. So this is like where you have a cell that could be an entire data set. Okay. And so you have like a data set like this, but then each cell of one specific column is like an entire data set for that specific row. So it could be a combination of a grade and a content area or something like that, right? So we're going to be working with nesting and unnesting. And then also we'll be working with dplyr row-wise, which does a lot of the same things. Basically, what we're going to do with that is we're going to do it all through per with mapping and nesting and unnesting the columns, but then we'll replicate it with dplyr row-wise. dplyr row-wise is really nice in a lot of ways, but it has some limitations in terms of it only works with a data frame. And I would say probably 80% of the time, that's what we want, maybe even more. But when you start to write your own functions, more and more, you're going to be wanting to do quite a few looping things outside of working in data frames. And so that's where per is going to be preferred. Okay, and then this is like kind of what the course is all about. When you have something that is repetitive, that you're doing many, many times, then you're going to write a function to do that thing. Okay, and so that's one of the big learning objectives, convert repetitive tasks into functions. But also then you're going to loop that function through whatever you want to do. And one of the things that's neat about this sort of an approach is that you can write a function that has a loop in it, right? And then you can call that function in a different loop. And so you will see very regularly people's code where it's like for I in, blah, for j in, blah, for k in. And then by the time you get down to this super nested loop, it's like, what in the hell is going on here, right? Like it's really hard to figure it out because there's so many layers of nesting. So from my perspective, anytime you're doing nested loops, you should probably pull one of those layers out, if not all of them, and write a function for that layer, okay? And that way, then you can just say, for I in whatever, do this operation for each one, right? And that operation itself might call a different loop, but your code is much more straightforward to read, and it's much easier to debug, okay? So we'll talk about that a lot too. Understand elements of good functions, and I say that in quotes because really a good function is a function that does what it's supposed to do, right? And then from there, there's a whole bunch of things that we can do for what's called refactoring, right? So you write an initial draft of a function, it's doing everything you want it to do, great. One of the things you can do then is, which we probably won't do much of, but you can write tests to make sure that that function is always outputting what you expect it to. And then you can go through the process of refactoring, which is basically changing all the internals of a function to make it more efficient, make it more readable, whatever, and then make sure that the output is still always the same as it was before, okay? So understand good elements of functions and things that should probably be avoided. I just mentioned one, right? Nested loops. We should generally try to avoid those. Write effective and clear functions is basically the same thing with the mantra of don't repeat yourself. Okay, so this week's specific learning objectives are to understand the requirements of the course and understand the requirements of the final project. And then from there, we're going to take a break, and then we're going to move into the actual content of today, which is data types. And so there we will be working on understanding the fundamental difference between lists and atomic vectors, okay, and how atomic vectors are coerced either implicitly or explicitly, okay? And so coercion means it's being converted from one type to another, okay? And then various ways to subset vectors and how subsetting does differ for lists. So if you have an atomic vector and you want to get out the second and third element, right, you do that one way. If you have a list and you want to get out the second and third element, you do that a different way. Okay, that's kind of what I'm saying. Potentially, actually, it could be the same way, depending on what you're thinking. And then the last thing is we'll talk about attributes a little bit. Okay, attributes are not the most important thing, but every once in a while they can be really handy. And frequently, this is the main reason why we'll talk about attributes. there will be things in other people's functions that you're using that are stored in the attributes. Okay, so you, like, let's say you fit a linear model, right? And you have some object. There might be something that you want to pull out of there that's stored in one of the attributes in that model object. Okay, so we'll look at attributes and sort of understand what they are, and then how we can pull stuff out of them and potentially set or modify them. Okay, any questions so far? Okay, textbooks. Advanced R, this is, in my mind, the best book on all of this kind of stuff, deep programming with R. This is not a book that I would recommend to people just getting started. It's more a book for this class, right? Like the third class in the sequence. It's a really good book. It's still written in, I think, a very clear way for the most part. But because the concepts are just very, some chapters that you might need to read multiple times, okay? Or at least paragraphs that you need to read multiple times. So this is a link to the online version. We can go to that real quick. And you can see it's here, right? And so I have, these are all the different chapters. We can go to functions, and it starts to tell us about it. In the actual course website over here, oops, I didn't add the link here. Let me do that right now. No, okay, hang on. Actually, I don't want those things either, but oh well. So when we go here, right, and then you go to the schedule, you'll see all the books here. These are all links to the full book. And then down here, you have links to the individual chapters. So you can see here, like chapter 3 is one of your required readings, which is on vectors. Okay, so all of those should link. These are a few other books that are also free. We've used both of them in the past. These are more like kind of reference for this class. There's a few required readings from this one, but not from that one. So from this one, I should do this here so you can see on Zoom as well. This course is structured in a pretty like sort of 2 sections, basically. The first section, the first 5 weeks, is mostly going to be on iteration. Okay, so that's different ways of looping. So we'll talk about data types today. Then we talk about base R iterations next week. Then we introduce per in week 3. Then we talk about batch processing. So this is a really common thing that I do, where like I'll get data from study, and it's all broken out by so I know in psych it's more common for them to be broken out by individual participant, right? So you can have a data set for each participant. And for me, it's more usually like I might have a data set for each classroom, or a data set for every content area, every grade, every combination of them, right? So it's a way of saying, okay, I could do something to one of these, but instead I'm going to read all of them in at once, and then I'm going to write some functions, and I'm going to apply it to every single thing, every combination all at once. Okay, so basically, and it's a way of really efficiently scaling your work. So instead of saying, okay, I'm just going to do it for this one, and then I'm going to copy paste and do it for this one, and copy paste and do that 52 times potentially, right? You just write a set of functions that then apply across all of these other situations. Okay, and then finally we'll talk about parallel iterations as well, which is basically when you have more than one thing that you want to loop through. So I don't mean parallel in terms of like parallel processing for computing, right? I mean more like you have 2 things you want to loop through at the same time to apply some function, or 3 things or 4 things or whatever. Okay, and then the second, supposed to be 5 weeks, but is really only 4 weeks in our case, is writing functions. And then we'll introduce Shiny as well. So we're going to have 2 weeks on Shiny, 3 weeks on, well, it's supposed to be, I guess we're going to have 2 weeks on 2 weeks on functions, 2 weeks on Shiny. Okay, but the final week was supposed to be sort of like an introduction to package development. There is a video from last term on that topic if you're interested in it. I think I have it linked now. If not, I will link it there for the week 10, okay, which we were supposed to do that there. So if that's a topic that you're interested in, I would really encourage you to try. It can be intimidating to say, I'm going to write my own R package, but there's a few major things that I would say that hopefully would make you less intimidated. A, you don't have to share your package with anybody, right? You can put it on GitHub if you want. That doesn't, like, you don't have to submit to CRAN. It's just your own thing, right? B, tons of people have their own R packages that are just their own individual functions that are useful for them and probably not anybody else, and that's great, right? And then C, once you're able to write functions, that's really the hard part, okay? Taking it from that step to, okay, now I'm going to wrap all of these functions into a basic R package is really not that big of a deal. It's not that much of a leap to go from I can write a set of functions to I can write an R package, okay? So, so I would really encourage you to consider that if you get to a point where you have some functions that are useful for you, even if they're not useful for anybody else, okay? If you get to the point where you have functions you think could be useful for other people too, that's when then you would probably submit to CRAN, and then there's probably a few other things you wanted to do, like build in some testing suites and things like that, but that's sort of beyond the scope of this course. Okay, we will have 3 labs starting next week. Okay, so we'll have a lab in week 2 and 3, and then we don't have another lab until I think week 7. Okay, and so, but in between there, we also have the take-home midterm, which is why we have such a big break in labs. Okay, so they are 10 points each. The first one is on subsetting lists and base R for loops. Okay, so we'll talk about lists today, and then we'll talk about for loops next week, and then at the end of the week, or at the end of class, we'll have the lab, okay? And then the second lab is on multiple models and API calls. So APIs are a very common way that data are stored on the web. And so you might need to write an API call to access the data from this API REST framework thing, okay? So there's a toy API that's meant just for educational purposes. It's around Pokemon. And so we're going to use that API. We're going to have you write your own calls to that API to retrieve some data, okay? And then we'll have a break from labs for a bit, do the midterm, and then we'll have one last lab that is on creating and applying functions, okay? All right, the midterm, there's actually 2 parts. So there's a take-home midterm and there's a in-class quiz, okay? So the quiz is not something that you should stress out about, so please don't. It's not that big of a deal, but there's a lot of stuff in this course that is kind of just like knowledge-based versus like doing-based, right? And so that's kind of the purpose of this quiz. So there's going to be multiple choice, fill in the blank type of questions. And then there will be, I think, one question that is identifying bugs in a code, in some code. Okay. And then I think there's a couple that are free response to where I'm like, where I say, you know, list the blah, 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 and then you have to just name them. Okay. So it's not that big of a deal. It is worth 10 points, but that's not like a huge amount. And I've never had anybody that has like totally bombed it. So I wouldn't stress about it too much. If you are stressing about it, let me know, and we can talk through it a bit more. Okay. But basically on the 22nd, you'll have the last like 25 minutes of class to do that. It's only 5 questions. So if you know the content, it should take you 5 minutes. It might take you more like 15 or 20 minutes, I don't think it's going to take you 25 minutes. So, yep. Oh, maybe okay. Well, whatever. Let's go look here. So, is it this one? Go here again. All right, so it is the 18th. Yeah, sorry. I just didn't update those dates on the slides is all. But yeah, so it'll be on the 18th. I think it's the last 20 or 25 minutes. I can't remember what I said, but I'll double check that of class. Okay. Any other questions on the take home or on the in-class quiz part of it? Okay, and then so the midterm is 70 points total. So that quiz is 10 points. And so the take home part is 60 points. The take home part is just exactly like the homework of last term. Okay, so you can work in groups. I encourage you to work in groups. If you do, I would ask that you use a GitHub repo. And I believe that I give a few points extra credit if you are using branches and issues and all of that kind of stuff. And basically, it's just going to be a homework assignment where you're going to write loops to solve problems. Okay, so it's not any different than any of the homeworks. It's just called midterm, and it's got more points associated with it. But yeah, this one, just like the homework last time, will be scored on a correct and incorrect basis too. So if you, so each question is going to be worth a certain number of points, as you can see if we go look at it. And so if you like totally bomb that section, then you'll lose those points. Okay, and if you get just like one or two things wrong, I might take away a couple points, but you know, I won't take away points, continue to take away points for that as you go forward. Okay, so let's go actually look at that real quick, just because it's already posted. So there's a couple different ways you can navigate this. You could go to assignments and then come down here and it says take home portion right there. So that links to it. The other way is you can go to tags and then midterm is right there. Take home midterm. Okay. So this data part is 20 points, right? And so you're having to read in some data and just format it basically. And then you're going to be installing this package, and then you're going to be looping, doing a bunch of looping with this. And so this is all, this whole section is 40 points. You need to recreate this plot showing that the two different methods you use to do the plotting come up with the same estimates. And then this part is you're creating this plot. This is for one district, abandoned school district, but you're going to loop this through the first 100 and produce this plot for the first 100 school districts. Okay, and then save it. And I think that is it. Yeah, it doesn't look like I did do extra credit for GitHub, but you are welcome to work in groups on that. And I encourage you to, but if you do, please do use a GitHub repo, okay? Because then I can track contributions a little easier. Okay. Any questions on any of that? Okay. So I've already gone over this mostly. 3 to 5 people, divide up the workload so that'll ease your work. I would, though, encourage you to not just say, just assign people different work and then go forth and don't worry about each other's work. Like, you're all going to be getting the same grade, right? So divide up the work, but then everybody should be reviewing everybody else's. And even just like stepping through it line by line should take 10 minutes, right? But that's going to be really helpful so that everybody's on the same page of, yes, this is what we want to do for this section. Okay, already posted, as I said. Final project. Final project has 5 total parts. Again, very similar to last course in terms of the structure. So there's an outline that's going to be due in 2 weeks. Okay. And then, but ideally, I would like you to have your groups finalized by next week. Okay, so same sort of thing, anywhere from 3 to 5 people in a group is fine. I don't want more than 5. If you have only 2 people, that's probably okay, but 3 to 5 is sort of the sweet spot. Okay, an outline is is due then after that, and then a draft of your data script. Then we'll do peer review just like we have before, and then finally your final project will be due. Okay, so we're not going to have any presentations this time, especially because we're already losing a week to a holiday. Okay, so what is the final project? There's basically two main options. Okay, the first is that you create a data product. Okay, so this is actually similar to like the capstone. The capstone is a data product. That's what you have to do. But here you can choose, just like capstone, whatever you want to do. Okay, so it's different from the capstone because you're not working with an organization and it's a small project, and you're working in a group to all figure this thing out together. Whereas your capstone is just you and you're working with an organization to build something for them, right? But you could create a brief research manuscript. It could be APA or it could not be APA. I don't really care. A Shiny app. Okay, we won't get to Shiny until later in the term, but if you're interested in that, I'm happy to support you. What I would recommend is that you try to get started on doing some of the Shiny readings earlier if you're thinking about doing a Shiny app. Okay, a dashboard. We did dashboards last time. It probably won't work super well unless you make it a Shiny dashboard to meet the course requirements. It might, I can't say for sure, but I'll tell you what the requirements are here in just a second. Or you could do a blog post, or if you really want to, you could do an R package, okay? And I say this is for the ambitious just because I'm not even gonna lecture on it because of it, us losing a week, okay? But again, I have tons of resources for that. I've helped lots of other people do that. So I'm happy to help you on that process if you'd like. Okay, so that's one option, is a data product. The second option is more of like a tutorial. Okay, and so this is probably best done through a blog post, or actually probably a series of blog posts. Okay, and basically you're going to approach the topics of this course essentially as if you were a teacher of people out there on the internet that want to know this stuff. Okay, so somebody's interested in getting more efficient with their programming. You're writing tutorials for them to explain to them how per map double works or whatever. Okay. The bonus of this is you can actually release this. You could share it on social media, and you might actually get some traffic. Okay, we've had some of that in the past. Okay, the main thing is though, whatever you do, I want you to make it your own. Okay, so don't do something that you're like not into, because you have to stick with it all week, all term. There is no course data this time, so you can use any data that you want, provided it's publicly available. Okay, it still needs to be something that I can access and that I can grade, because I need to be able to run your code. Okay, so what you have to have in either of these two options, whether you choose the data product or you choose the tutorial, is everything needs to be on GitHub. Okay, the only exception to that might be if you have data that are too large to put on GitHub, and in that case, we should chat and figure out a different alternative for you to be able to make that data work from the code in your GitHub repo. Okay, so it should be a publicly available data set, and then you should have a team of, this time I've said 2 to 5, which is kind of what I said verbally. 3 to 5 I think is ideal, but if you want to do a pair, that's fine too. So this is unfortunately still a class, right? And so we can't just open it up entirely and say, okay, do whatever you want, because I want you to be able to show me that you can do the stuff that we're doing in this course. Okay, so there's a few things that the grading criteria are going to possibly force you into making some decisions or writing some code in a specific way that you maybe would do it differently otherwise. And that's okay, right? It's okay if some of these examples, some of the ways that you use these functions that I'll introduce in a second are a bit contrived. Like, that's all right. Don't worry about it. Okay. The main point is that you're using them and I can see that you're using them and you understand what you do. Okay, so here's the grading criteria. No code is used repetitively. Okay, so no more than twice. This is a really this is what this course is all about, right? Collapsing, 1,000 lines of code down to sometimes less than 100, right? So that's the first part. More than one variant of per map. So we're going to be using per a lot. Map is like the base function, and then there's a whole bunch of different variants from that. So you have to use at least one variant of per map, which shouldn't be hard. And then at least one per function outside the basic map family. And this will be a little bit more difficult. So walk is a good one. Reduce is a little more tricky. And I didn't like see use cases for this for a while, and then I saw them fairly regularly. But the thing with reduce is like, it's kind of hard to come up with good examples for it. So I don't know if my examples are great, but it's definitely different than basic map one. There's also modify, there's also safely, there's also quietly. Okay, so we'll talk about all these other per family of functions that are not necessarily like the map family. Okay, and then at least one instance of parallel iteration. So this should be map2 or pmap. And then at least one use case of this per nest, mutate, blah, blah, blah. Okay, so this is the list column stuff. You also need to write at least 2 custom functions. Okay, so these are brand new functions that never existed until you wrote your final project. Okay, those will be graded at 10 points each, so 20 points total. Okay, each of those functions should do one thing, and it should do it really well. Okay, there is, I think, when people first start writing functions, there is this desire to make a function do all the things. And it's much, much better to have multiple functions, each doing one thing, that then culminate to one additional function that just calls all of those other functions, than it is to have one gigantic function. Okay. This is important too. That function, the functions that you write, they may replicate something that is either in the tidyverse already or is in base R already, right? That's totally fine. This is really about practicing these skills. So if your specific use case is, I'm going to write a new function for the mean that removes missing data by default, right? That is fine. Okay, that's a really simple example and something that we will actually be doing in a lab. So I would hope that you'd be writing something a little more complex than that. But the point is, if there's a function that already exists and you want to write your own function that replicates that behavior, and maybe you just want to sort of change some of the defaults, that's fine. Okay, and in fact, in some ways, that's nice because then you can compare your output with the other function and make sure they're producing the same output. Okay. And then your code should be fully reproducible and housed on GitHub. So this is all the same as last time. Basically, when it comes time for me to evaluate your final project, I will fork it, then I will clone it, then I will basically hit knit or build website or whatever. And everything that I see on my local should match exactly what I see on your deployed website or dashboard or Shiny app or whatever. Okay, if there's any differences, you will lose points there. And then no obvious errors in the chosen output format. So this is generally not a problem. The only time I've really run into issues with this is when people say try to use their own CSS for things, which is awesome. I totally encourage you to try that. But then they end up with things where like the title is like running off of the page and you can't see it and you can't scroll to see it, right? Or like the font is so big that it's going past its bounds and then it gets cut off or whatever, right? So generally that's like not that big of a deal, but there shouldn't be anything like that in your final project. Okay, and then it should be deployed on the web and shareable through links. So this is just, again, like last time. If you are doing a Shiny app, you'll probably have to publish through shinyapps.io, which you can get a free website, free account for, and you can have, I think, up to 5 applications for free. So we can deploy that way if you're doing a website or anything or a standard dashboard, then you can just deploy through GitHub Pages. Okay. All right. The outline, which is due on the 18th, so that's 2 weeks from today, I think, right? No, 3 weeks? I don't know, whatever. Whenever it is, the 18th, however long that is. You will need to have your group finalized next week, right? And then you should probably pretty quickly be working on your outline together. It should have these 4 components, okay? Description of the data source. So you should all agree on a data source that you're going to use. And then the purpose, so are you going to do something that's more tutorial based, as we just talked about, or are you going to build more like a data product, okay? That's similar with the chosen format. But with the chosen format, it could be, you know, say you go substantive, you could go substantive and have a Shiny app, or you could go substantive and have a blog post or whatever. Even with tutorials, you could have a tutorial-based Shiny app, right? Those are really cool. It's also pretty difficult. So I would caution you against that. But if you want to try to take that on, that would be really cool, right? And then the last one is just what lingering questions you have. So if there's anything that you're feeling uncertain about, please let me know, and then I can give you feedback on that, okay? So just like last time, the main point of this is for you to share with me sort of your thinking in the process, and then me to give you feedback on that thinking and let you know sort of where you're at along the way and if it looks good or what should possibly be changed. Okay. Yeah, please include all of the components. Okay, after that, we don't have anything that's due for the final project until very late in the term, right? I think it's week 8. And at that point, you should have a draft of your final project done, okay? I say draft, and I mean that like very, very rough draft, right? It does not have to be fully polished at all. So there might be lots of things that are still sort of left hanging, but the direction should be obvious. It should be very clear what you're doing from your draft, okay? If there are any grading components that are missing that we just went through, right? If any of those are missing at this point, then that's a bit of a red flag, okay? You should have all of those present. And when it comes to peer review, which this is what this draft is for, right? You should be first and foremost looking for all of those grading components and then giving them feedback on if they're missing any or how you think they could improve those sections, okay? So this is all provided to your peers for peer feedback so we can learn from each other. Okay, the peer review process is going to be exactly like we've done in the past. So your group will be assigned a bunch of different reviewers. You will individually be assigned multiple groups to review. Okay, I don't know if I have it on here. I don't. I think I'll have to check the syllabus, but I think I said 3. Okay, so you'll have 3 groups that you will review. All right, so that means your individual group is going to be reviewed multiple times, right? And then you will review most everybody else's groups, depending on how the groups sort of shake out. But it's really an opportunity for you to get feedback on your work, but also for you to see the approaches that other groups are taking and how that might sort of change your thinking on how you would do it. Like, oh, I see they're going this way, like I would have gone this way, but they both end up working, and that's kind of cool, right? Okay. Oh, 2 groups. There it is. All right, so you only have to review 2 groups. Okay, so this is, again, just like last term, I'm going to require that you submit a pull request for your peer review. Okay, so this is the process for that pull request. You will go to their repo and you will click the fork button. That will then make a copy of their repo on your account. Okay, from there, you will clone their repo from your account, because then you can make commits and push to your account, right? Because you own that repo at that point, right? So then you will do your review. And when you're doing your review, you can embed comments in the code, but you can also just straight up suggest code edits, right? You can change the code that they've written based on how you think it might be improved. And so I'm asking you to please do both of these things, okay? Embed comments, but also please do try to change their code somehow, right? This could be even small things like code styling, right? For many of you last term, I talked about code styling on the final project. Code styling, like it's a super important thing. It's one of those things where I think when people first start getting into coding, it's like, well, what does it matter? It all works if I put it all on one line or if I stretch it out across a bunch of lines. And like, I don't care. They look the same to me. But the thing with code styling is it's very much like writing with proper punctuation, right? And proper grammar. If you're not capitalizing anything and you're not putting commas or periods anywhere, then you just get these giant run-on sentences and it becomes difficult to understand what's happening, right? Similarly, with your with code, you can get in these situations where it keeps connecting to my headphones, which are you can get in these situations where your code is like stretched out forever and I have to scroll this way to see it, or you know, or you have everything is kind of jammed together on the same line. And yeah, it works, but if you have to get to a point where you're debugging that code, it's going to be much more difficult than if it's following a coherent style. Okay, so style edits are very much appreciated. You do not have to follow a specific style. I will never tell you you have to follow a single style. There are lots of styles out there. The important thing is you follow a style, any style, whatever it is, just be consistent with it, okay? All right, so after you've suggested edits to their code, then please submit a PR, okay? So what you'll do then is you will commit your changes, you will push those up to your fork, right, on your account, and then from there you'll go back to their account and their repo, and you'll say submit pull request. That will then take you to a place where you can open a new pull request, and you will have to say compare across forks, because by default it's going to look at different branches within the same repo, right? So you want to say, I want to submit a pull request not from a different branch, but actually from a fork, okay? So you submit that, you'll be able to then select your fork. So you'll see your account / the name of the thing, and then you'll submit the pull request there. When you're submitting the pull request, you'll have a section where you can write some text, right? So that's where you should write your overall summary of your review. What did you think about it? What did you like about it? That sort of thing, okay? And as always, we want to be super encouraging, super positive, and not overly negative on any of this, right? We're all learning. The last thing that I don't have here is it would be great if you could also tag me at that point. So just @DataLorax, that's my GitHub username. And then I will get a little notification telling me that you submitted that PR. I'll just go in and basically look through your pull request, look at your edits and things, and then write a little comment like, great review, I liked this part, or whatever. And then after you've submitted your 2, I'll give you your points, okay? All right, so grading, there's 200 points total, 10 points for each of the 3 labs, so that's 30 points. The in-class midterm, that's another 10 points. The midterm take-home, that's 60 points. And then the final project, which is 100 points. So the final project is broken up across these things, but you can see, because you know it's all on 200 points, it makes the percentages easy. So the final project is 50%, it's half your grade, right? And the final product is about 30, well, it's exactly 35% of your total grade, okay? Any questions on any of that? Yep. Yes. but I don't have them currently. But I will. I'm gonna take a note from it myself here real quick. Okay, so I want to say email past. Okay, so I'll do that after class. Okay. Other questions? Okay. This is pretty straightforward as well, I think. This is just the percentages, how they line up based on the number of points you get, and then actual percentages. So anything 97% and above is an A plus, between 93 and 97-ish is an A, etc. Okay. All right. A note on feedback. This is a little bit painful for me to do, but I think it's necessary. Last term, I gave you feedback, individualized feedback on everything, right? You submitted a lab. I would review that lab in detail and try to give you as detailed feedback as possible on that lab. This term, I just don't think I'm going to be able to do that. Okay, so instead, what we're going to do is, just like we always did, we will review the labs in class. Okay, so you will be able to see at that point everything that I did in the lab, the way that I approached it. Okay, and that doesn't mean that that's the only way to approach it, but you'll see the way that I approached it. Then when you turn in the labs, they'll be completion based. Okay, so if you get it in on time, you'll get full credit. If you get it in late, you'll probably still get full credit, as long as you just tell me that you're going to turn it in late. All right. And then you can ask me questions as we're going through it together in class. And if there's still specific questions you have after that, you can either stay after class, that works great for me, or we can set up a time on one of those Fridays to go over whatever part that you might have a question on still. Okay. So I will, though, still be giving you feedback on your midterm take home and your final project. Okay. So those will just be working on the weekend. One last note, week 6, I will be out of town. And so that class will be fully remote. Okay, so so Zoom is always an option, just like last term. But this on week 6, it will be the only option. Okay, so I'll be in Chicago, so I will be presenting from my hotel room. Okay. I do also want to talk about the remote thing just a little bit too. I am, again, like super happy for you all to be remote whenever you want to be remote, for whenever it works for you. Specifically, if you have something going on in your life that makes it easier to be remote, and it's not just like, I don't feel like walking across campus because it's raining. Right? However, specifically on the lab days, it would be really, really, really helpful if you could try to be in person. Okay. The labs don't really work when you're on Zoom because they are, for me, a great source of formal assessment or formative assessment for me to sort of check what you're doing as you're doing it and kind of be able to peek over your shoulder. And I know that can be like a little intimidating. I don't mean it to be that way, but it can be really helpful for you too, because you can work along, and then as you get stuck, I can come in and talk you through it and you can get unstuck. Okay. And so I would really love for you to try as much as possible to be in person for the labs. For the other days, it's not as important. I prefer to see your faces in public or in person, but if you don't feel comfortable with that for any reason, or you have something else going on in your life, specifically if you're not feeling well, then please do attend by Zoom. Okay? Any questions on that? All right, communication is the same as last time. If you have anything else that's going on in your life that is making it difficult to complete the assignments, you don't have to tell me what it is that's going on in your life. That's your business. But please do talk to me so that I'm aware that you have something going on and that it's not just like, oh, all of a sudden nothing is being turned in, right? And you're not attending classes and I don't know what's going on, right? So if you feel yourself start to slip behind, even if you don't have other things going on and it's just this is a really freaking hard class, right? And you feel yourself sort of not being able to keep up, again, please try to reach out and then we'll talk through it, okay? And we'll try to figure out how to get you back on track, okay? So communication is never a bad thing. Please reach out to me anytime and as frequently as you want, okay? I'm here to help. All right. Let's take a break there. This got messed up. Take a 5-minute break, and then we will return to talk about data types, unless anybody has any questions. Let's go ahead and get started again. So the rest of the class today, we are going to talk about basic data types in R. So I'm going to give you this little pop quiz about vectors, okay? So what I'd like you to do is those of you on Zoom, I can put you in a breakout group here in just a second. But basically just either partner up or pair up with 2 or 3 of you, whatever, and just go through these. So what are the 4 basic types of atomic vectors? If you have no idea, that's fine, but just take a guess, just kind of talk through this stuff. What function creates a vector? Okay, and then true or false, a list, an R list, is not a vector, okay? And then what is the fundamental difference between a matrix and a data frame, okay? And then the last one, what does coercion mean and when does it come into play? So again, if your answer to all of these is I have no clue, that's okay. I'd still like you to talk with your neighbor and kind of talk through what do you think it might be, all right? And then we'll go through them all together. Make sense? Okay, go ahead and get started. And then those of you on Zoom, I'm going to create a breakout group for you real quick. Okay, so what do we think? What are the 4 basic types of atomic vectors? Who feels like they know one of them? What do you think is one type of an atomic vector in R? Numeric. Okay, close. There's actually 2 types of numeric vectors. Others? So we'll say numeric, that covers 2. And then what did you say over here? Character, right? So strings. And then there's one other one. Logical. Good. Okay, what function creates a vector? C. Exactly. Just C. That's the function. Okay? Which stands for concatenate, I think, originally. True or false, a list, an R list, is not a vector. What do you think? False. It is a vector, it's just not an atomic vector. Tricky. What is the fundamental difference between a matrix and a data frame? Any ideas? No, they are. They're still, yeah, mutable. Anybody on Zoom have any idea on this one?
The different types of data you can use in a data frame.
That's exactly right. So a matrix, every element of the matrix has to be of the same type. So they can all be character, they can all be logical, or they could all be one of the 2 numeric types that we'll talk about in a second. But they cannot be a mix of character and numeric, for example. Okay, in a data frame, you have each column is an atomic vector, usually an atomic vector, unless it's a list and then it's just a list vector. Okay, but usually it's an atomic vector of one type. So each column is a specific type, but the columns can be different types. So one row can have a bunch of different types in it. Okay. What does coercion mean and when does it come into play? I kind of talked about this earlier, but ideas on what coercion means? Anybody on Zoom? Okay. Coercion just means that we're going to coerce, so we're going to change the type of for one data type to another. Okay, and this happens very regularly when we're combining vectors. So let's say you have a character vector and you're trying to combine it with a numeric vector. Okay, only that vector can only be of one type. It cannot be of both types. Okay, so then it has to coerce, and so one of those has to take precedence. Okay, so that the entire vector is just character or the entire vector is just numeric or whatever. Okay, so that's what coercion is, and we'll talk about coercion rules here in just a second. Okay.
Question.
Yep.
So like when you make something like as factor, as numeric, like, but that's not one of the main vector types. So what are
Correct.
those
Yes.
vectors?
So this is a great question. So the question is about factors and saying like as dot factor or as dot numeric. Those I just said are not part of the atomic vectors, the fundamental types. That's because, and we'll actually go through this in slides here in just a little bit, factors are composed of multiple types of atomic vectors. Okay, so atomic vectors are called atomic because they are literally like the atoms of R. Okay, so there's atomic vectors and lists, and those two things together build up to form every data structure that you work with in R. Okay, so for a quick example, a data frame is actually a list, and we'll look at that also later. Okay, so a data frame is just a special type of list. That's it. Okay, factors are built up from multiple different types of atomic vectors working together. Okay, and we'll see exactly how here in a little bit. Okay. Other questions? Okay, so the four fundamental vector types, atomic vector types, are integer and double. Those are the two numeric. So integer, obviously meaning, just a singular number, 1, 2, 3, 4, and then double, which is also called float in other programming languages. Okay, and so or floating point, right? And so those are like 3.27, right? So any sort of precision to the number beyond the integer itself is of type double. Okay, and then logical is just true or false, and then character is like a string. Okay, integer and double are both numeric. So if you say as dot numeric, it's usually going to coerce to double, but sometimes it might coerce to integer. I'm not really sure. Okay, so when we want to create vectors, we use C, right? And here is an example of creating each of the different data types, right? So to start, I'm creating an integer. This is really strange, but the way that you denote an integer in R, and this is actually across other programming languages as well, is with an L after the number, okay? And so that's like, well, why? And like, I don't have a really good answer for you. I can tell you there are what's called long and short integers. And in R, I believe only long integers are implemented. I have no idea what the difference between long and short integers are, but that's where the L comes from, okay? So if you want to explicitly say this is an integer, not this is possibly a floating point, double, then you use that L, okay? So this is integer very explicitly. This is of type double. Notice I have inf and negative inf on there as well. Those are of type double as well, okay? Logical, just some trues and falses, and then character, in this case, I've got a character string of some colors, okay? So coercion, vectors must always be of the same type, unless it's a list vector, but atomic vectors must be of the same type, okay? So if you try to mix types, implicit coercion will occur. That was hard to say. All right. Implicit coercion is always going to default to the most flexible type. Okay, so think about these types here again for a second. Think about the data that you can store in those types. Okay, the more data you can store, the more kinds of data you can store, the more flexible it is. So looking at this, what do you think is the most flexible vector type or data type rather? Character, exactly, because you can put a number in a string, you could put true in a string, it could encapsulate everything else, right? What's going to be the least flexible? Logical, because logical is true or false, and that's it, 2 values, right? And so double and integer are kind of in between those, but which is more flexible between double and integer? Double, because you can store an integer as 3.0000000, right? But you can't, if you try to store 3.27 as an integer, it's just, you're just going to get 3, right? And in fact, it could be 3.97 and you would still get 3, right? If you coerced it to an integer. All right. So in order, the most flexible is going to be character, then double, then integer, then logical. Okay. So that's how they're going to coerce. So for example, when we're looking at this, if we combine 7 as an integer and 3.25, it's going to coerce them both to double because that's the more flexible type. So it's going to basically try to maintain the data as much as possible without losing any information. Okay. If we do 3.24 true and April, we get a character vector in return because again, we can store all of that information in a character, but we cannot store all of that information in type double or in type logical. Okay, and if we say true and 5, the true is going to be coerced to a 1, the falses are coerced to 0s. Okay, so if anytime you're coercing logical to numeric, the trues will become 1s, the falses will become 0s. Okay, so in this case, we're not really losing any information here either. Okay. You can also do, so all of that is implicit coercion, right? You can also do explicit coercion. So where I'm explicitly saying, this is how I want it to be coerced, right? So here I have 7L, so 7 as an integer and 3.25, but I'm wrapping the whole thing in as dot integer. Okay. Now, very trickily though, this doesn't really do probably what you think it does. It's not, because the precedence is going to come inside first and then outside. Okay, so it's going to actually do its implicit coercion thing here first, and then it's going to do as dot integer to the result of that. Okay, so in this case, we don't lose any information. We get 7 and 3, which is what we would expect. And on this, in this case, I say as dot logical, and I get NA true NA. Okay, because we can't, but this one actually can be coerced to logical, but it couldn't, because once we do this part of it, it's going to coerce them all to be character, and then from there it's trying to pull out the logical from it, and the only one it could find was this true. Okay, and then the last one, as dot character true 5. So this is a probably better example of what I was just talking about. That implicit coercion occurs first, and then the explicit coercion. All right. So when I call as dot character on this, I get 1 and 5 as my result, because true is first being coerced to 1, and then both of those together are being coerced to as dot character. So if you really wanted to maintain everything in here as it is, you would have to call, you know, as dot logical or as dot character or whatever on each element of the vector. Okay, rather than to the entire vector, because if you do the entire vector, that implicit coercion is going to occur first. Okay, if you want to check the type, you can use the function type of. Okay, so I can say type of and do some implicit coercion and just kind of test myself. In this case, I get double, right? So this integer is being coerced to type double because we have 3.25 here. Okay, and this one I'm explicitly calling as dot integer, and so we get integer type back. Okay, type of it is nice because it tells you the specific type. So of those 4 different types, right? Whereas other functions are going to be less, like if you did is.numeric, right? It would return true or false, but it's not going to tell you if it's double or integer, right? There is also is.double and is.logic or is.integer. So this is, I talked about this already, but when you're coercing to logical, specifically with numbers, the results can be a little bit unexpected at times. Okay, so this is an example where the results make total sense, right? The zeros get coerced to falses, the ones get coerced to trues. But what's not always clear is that any non-zero number will get coerced to true. So here I have 0, 5, 7.4, negative 1.6, and 0. And the only ones that are false are this one and this one, right? So all of these ones that are anything except 0, even if it's a negative number, those get coerced to true. Okay? And so that can be confusing as well. Why do you think we have the NA here? We already talked about this. Implicit coercion is occurring first. Okay, so in this one, right, if I call as.logical on this, right, and this one, they're going to true. So you would think looking at this, that this should be true, but it's not because it's first being coerced to character. And so then when you're calling as.logical on it, it can't find it. It's not going to convert it back to numeric and then convert it back to logical. Okay, piping, this is just a very quick detour. Typically, we use piping within the tidyverse, right? When we're piping a data set to some other functions. But we can do this actually with anything. You can use the pipe for anything. So here, right, I have type of as.integer C, and I have a vector. So I've got all these things wrapped, and you kind of have to read this inside out. So here's the vector, and then I'm calling as.integer on it, and then I'm calling type of on it, right? Whereas with the pipe, you can do the same thing, but you can do it in a more natural way. Here's the vector. I'm going to pipe that to as.integer, and I'm going to pipe that to type of, and I get integer. Okay, so you can do this either way. I am using the McGritter pipe here because the base pipe is still, I think I have that on the next slide. Yeah. So the base pipe is as of R 4.0. Probably most of you know about this, but the as of R 4.2, which is coming out in April, I think, the base pipe is going to be, in my opinion, significantly improved. The main thing that was a bummer about the base pipe is that it, with McGritter, it's like if you wanted the data to be the third argument instead of the first, you could just put a dot to specify where the data should go instead. With the base pipe, you have to do this lambda function thing, and it's just a lot more text, and it doesn't really work very well. But as of R 4.2, you're now going to be able to do the exact same thing, but you'll be able to put an underscore where the data set's supposed to go rather than a dot. Okay, so it'll basically be, I think, as of R 4.2, I'm going to no longer use the McGritter pipe because base pipe works great. So, all right. Real quick pop quiz. You can just do this internally, but I'd like you to look at each of these 4 types, and then you can write it down if you want. Just predict for each of these what the end result is going to be. So what type is this one going to be? What type is this one going to be, etc. Okay, 1 minute, go ahead. Okay, first one. How about we do it this way? Raise your hand if you think it's going to be logical. Raise your hand if you think it's going to be double, integer, character. There's not even a character. All right, so double is the correct answer, which we'll see here in just a second. Second one, 1L and false. Raise your hand if you think it's going to be logical. Integer. Good. That one will be integer. And this one, we've got 7L, 6.23, and 8 in quotes. Logical, there's not even one there, right? Integer, double, character. Good. And last one, logical, integer, character, double. Okay, let's go look at them. First one, double, right? And that's because we have this one, logical is the least flexible, then this one, right? So double is more flexible than integer because they can contain integers. Double can also contain true or false because they get coerced to zeros and ones. And so everything can be maintained. And so we get type of double. For the second one, we have 1L and false. So when we look at those, they are going to coerce to integer because integer is slightly more flexible than logical, right? Because logical is only true, false, whereas integer is like 1, 2, 3, 4, 5, 6, 7, 8, all the way up to whatever, right? For this one, we have integer and double. So double is the more flexible. But then we also have 8, and this is a character one. So as soon as we have a character one, basically we know our answer. It's going to be character. That's the most flexible one. And it has to be character or else we're going to lose this information. If we tried to coerce this to anything else, it's going to end up as NA, right? So we end up with character. And then same thing here, we have true and we have false, but that false is a character. And then we have these two integers. So we end up with character. Okay, so very easy rule of thumb. If there is a character in the vector, it's going to coerce to character. Okay, so I want to pause for just a second. All of this that we've gone through so far might be like kind of interesting, but it's kind of also like, why does all this matter, right? But this is sort of like the building blocks for where we're going later, okay? Because when you're writing functions, you have to be careful about this kind of stuff because you're going to have some sort of input. And if that input is different than what you expected it to be, then you might have some implicit coercion occur and then everything else in your function breaks, right? And so, with most of your many functions, you might want to check the type first of the input. You might want to coerce the input to be something else, etc. Okay. All right. So that's atomic vectors. A very quick run through on atomic vectors. Let's talk about lists now. So lists are vectors, but they are not atomic vectors. And the fundamental difference between a list and an atomic vector is that each element in a list can be a different type. Okay, so here's an example where I say list A as a character, 7L, so an integer, 3.25, double, and true, logical. And when I look at my list, it's all maintained, right? Not a single thing is lost. We have the same data type for all of them. Everything is happy. Okay. So each element of the list is another vector. Okay, every single time. In the previous one, those vectors were just of length 1. Each of them were just one of length 1, right? But a list pretty much always is going to, well, not pretty much, I'd say always is it going to include other vectors, possibly including even other lists. Okay, and having deeply nested lists is very common and something you will see a lot as you start to dig into functions more. Okay, so each element of the list is another vector, possibly atomic, possibly not. So it could be another list. The prior example, we're all scalars. so single entries. But lists, this is one of the things that is really neat about them, that make them so incredibly flexible, is that not only do they not have to have the same type for each element, but each vector can be different lengths. Okay, so here, this one is of length 3, then 5, then 2, then 4, and it all works fine, right? It's all maintained in this singular list structure. Okay, if you've never seen a list before, really, in R, that's totally fine. If you've worked with lists a bunch in R, and this looks like super obvious to you, that's totally fine too, okay? But we're probably going to dig into lists at a deeper level than you have before, okay? So real quick summary here. Atomic vectors must all be the same type. An implicit coercion occurs if not, okay? Lists are also vectors, but not atomic vectors. And each element can be a different type and length, okay? So lists are super, super flexible, which is really nice, but they can also be more difficult to work with and harder to sort of wrap your head around what's going on with them, especially once you get to more nested lists, which we will be working with, okay? Okay, what I'd like to do now is just for 5 minutes or so, work with a partner and basically just kind of quiz each other, okay? So I think this is the last, yeah, this is the last thing we'll do with vectors. And this is just with atomic vectors again, but just basically each of you create, 4 vectors, one of each type, and then go through and just kind of quiz each other and say, okay, I'm going to combine these two. What do you think it's going to be? And then actually run the code and see what it ends up actually being, okay? And hopefully you'll be, by the end of this, to the point where you're like 100% right? You're able to fluently figure this out, okay? That's the point of this. Okay. Moving on. How was that first, real quick? Did you feel like you were pretty fluent by the end? Good. All right, moving on to attributes. So what are attributes? Attributes are metadata. So what's metadata? Metadata is data about the data. Okay, so the most common of these, the most common metadata is like something like the column names in a matrix, right? So the column name is a form of data about the data, right? That column. Or row names, similarly, data about the data, right? So attributes are just metadata about either a vector or elements of the vector. Okay, so you can have metadata for the entire vector or for elements of the vector. And these attributes can really fundamentally change the way that the vector will look and behave. Okay, so other data types in R. Atomic vectors themselves we use a lot, right? But they're only a small fraction of the total number of data types in R, including things like data frames and matrices and factors and dates and all sorts of other stuff, right? So how did we come up with those? Well, I already just told you a bunch of those. But we use our atomic vectors to create these, all right? So again, the atomic vectors are the atoms of R, and so we use them with attributes to build up other data structures, okay? So I've already kind of mentioned this too. All right, so example. So please follow along. I'll give you just 30 seconds here. Load the Palmer Penguins data set, and then just go ahead and call attributes on penguins. In this case, I'm saying penguins 1 through 50. That's going to give me the first 50 rows. Okay, and then I'm putting a comma and then blank over here, which is saying all the columns. Okay, and I'm doing that because I just want to limit the output for the slides. So you could actually omit that altogether and just say attributes penguins and it'll just list all the row names. Okay. So what we see here when we do this, when we call the attributes function on the Penguin's data frame, we can see that it has 3 attributes. Okay, it has names, which are the column names. Okay, it has row dot names, which are the row names, and in this case, they're just integers. Okay, and then it has the class. All right, and in this case, there are 3 classes associated with this object: TibbleDF, Tibble, and data.frame. Okay, and so the class is quite a bit more complicated, so we're not really going to talk about it too much, but basically this is the fundamental thing that makes it change the way it behaves. If you removed TibbleDF and Tibble from the classes, it would just be a standard data frame. Okay, so those TibbleDF class make it behave like a Tibble instead of a data.frame from base R. Okay. All right, so when we look at the head of Penguins, now you can see some of those row names, 1 to 6, because we called head, so we only get the first 6 rows. And we see the column names, which are names, right? But we don't see the class there, that's fine. All right. If we want to access a specific attribute, rather than listing all the attributes, so we call attributes on a thing that's going to list all the attributes. If we want to actually access one of the attributes, we use this ATTR function. Okay, ATTR meaning attribute, but abbreviated, right? You then first give it the name of the thing that you want to pull the attribute from, and then the attribute you want to pull as a character, right? So coming back here, when we did this, we looked at all the attributes. You can see we have names, row.names, and class. So to pull one of these, we'd use ATTR on Penguins and pull the class. Okay, then I get just the class back. Okay, you could also do names and you would get just the names back. Now, in both of these cases, there are other functions to access these attributes specifically that you would use and that should be preferred over this method. Okay, so this is not necessarily showing you how to access the class attribute. Instead, you would just use the class function, right? And similarly for names, there's a names function, right? But it is showing you how to pull any attribute from an object. Okay, so it could be any arbitrary attribute. So yes, this is just repeating what I said here. So class and names, those are the functions you would generally use for each of these 2 things. And the reason why is these functions themselves may behave differently based on the object. And so, for example, the only time I've really been bitten by this is if you dig into one of the IRT model objects and pull out the coefficients, you get factor scores. If you call coef on it, you get item difficulties. Okay, so so if you dig in though and pull the coef object, you get factor scores. Okay, so generally the package developers are going to write these functions to work for you in the way that you would most commonly use them. All right, so generally those would be preferred. They're also just more readable than the above. All right, but this is the general way that you're going to access any attribute from an object. Okay, so in this prior one, right, the thing I'm asking for attributes from is this Penguin's data frame, the entire data frame, right? But that may not always be what I want. Maybe instead of getting the attributes for the data frame, I want the attributes for a specific column. Okay, so instead I can look at, for example, the attributes of Penguin's species, and we can see, oh shoot, I messed this up. This is not what that's supposed to say. I don't know why that happened. But we can see that you have this levels attribute, and yours would not be these levels, right? Those are what I redefined them as. But for some reason, they got into my slides at this point, when they should be at a later point. So you can see for species, though, let's go back to species. Yeah, so it's messed up here too. But yours should say species, and you should see that it's a factor, right? That's because it's a tibble that you can see it, right? So it's a factor, which is great. And then you're going to have these levels that have the levels of the factor, and then the class, which is going to be factor, okay? And that's great. That tells you more information about this. If I called attributes on the bill length, that's just a numeric column. It has no attributes that are associated with it, okay? So from here, you can probably start to see how factors are made up, right? They are actually an integer vector that has these levels and class attributes associated with them, okay? So this is how we can redefine them. Again, this is not generally how we can redefine the levels, but it works, right? We can pull the levels from the species attribute, and then we can redefine them as something else. So I've redefined them in this case as big one, little one, and funny one, right? And then when we look at, so if you ran this code on your local after having it previously just from Penguins, you would actually see this change. So now this is what it looks like. This is how it should look now. But before, we should have had a deli and all of the chin strap and whatever. Okay. And so you can see it looks like this now. Does that make sense? Questions on that? So all we're doing here is I'm pulling just this vector. And this is a vector, right? This is a character vector, which is the levels of this factor. And then I'm going to redefine them as something else. And as long as it's the same length as the previous one, it's going to be fine, and it's going to redefine them. Okay? Dimensions. We'll talk more about factors again here in a minute. Dimensions is another super important one. So again, please follow along if you can. So here, I'm creating a matrix, right? So I'm just saying, give me integers 1 to 6. That's going to be in my matrix. And then I'm going to say with the number of columns equal to 2. Okay? Notice when I do this, the matrix fills vertically rather than horizontally. Often we think of these more in a horizontal way. And so you can use by row equals true, which we'll see in a minute. But I'm going to kind of show you why it fills vertically here in a second. Okay? So you have that matrix. Now we can check out the attributes of the matrix. Okay? So we call attributes on it, and we see it has this dim attribute. Okay? And it's a vector, an integer vector of length 2. And that those dimensions are 3, 2. So this is the number of rows, 3, and this is the number of columns, 2. Okay? So we can modify that, right? What we can do is instead of saying we want a 3 by 2 matrix, we're going to say instead we want a 2 by 3 matrix. So what I can do is call the attribute m called dim, and then redefine that to be 2, 3 instead of 3, 2. And then when I look at m, I get this. And notice it's still filling vertically. 1, 2, 3, 4, 5, 6. Okay? And once again, you can get this from just calling dim rather than attr. But we're doing it sort of the more, I don't know, full way, I guess. Okay. Alternate creation. Here is what is kind of actually happening. And this, I hopefully will help you see why it's filling vertically. Okay. So here I'm first creating an object I'm calling v, right? Which for vector. And it's just 1 to 6. Okay. Then I'm going to assign a new attribute to v, which I'm calling dim. And this is, I don't think you can do this by calling dim on this because it doesn't have any. Actually, I take that back. I think you probably could. But I'm creating a new attribute here for v, which I'm calling dim, and I'm assigning it as 3, 2. Okay. And so what it's going to do is it's going to take those first 3 and just basically cut it there. Then it's going to take the next 3 and then it's going to staple them together. Okay. So that's why it fills by row like or by column like this. If we wanted it to fill by row, we can use by row equals true with the matrix function, or more convoluted, you could also set the dimensions to 2, 4, and then you just take the transpose of that. So this kind of walks through how to do that manually. Really not important, but just sort of a FYI. I don't know. I thought it was interesting. Okay. Names. So names are one of the most common attributes, maybe the most common attribute. And so with matrices, we usually have column names and row names, right? So we can assign these a couple of different ways. This is one way where I'm creating a list here, right, that has 2 elements in the list, 1, 2. Each of those are character vectors, and they are the names for the given dimension. Okay, so just like the dimension goes row columns, I'm going to put the row names here, and then I'm going to put the column names here. So it follows the same order, rows then columns, right? And then I would just say attrv dim names, and then I'm going to assign that this thing up here, and I get this. Okay. Another way to do this, which I think is actually a little more readable, is to just say row names on v2 and assign them, call names on v2 and then assign them. Okay. But either way, these are attributes of, again, just a vector. Like this is still underneath the hood. This is still just an atomic vector, but it's got these attributes that are associated with it now, so it functions as a matrix. Okay. All right. You can also have arbitrary metadata. This is not something that I do super commonly, but every once in a while it can be very nice. Okay. So here's an example where I have v, and then I'm creating another attribute, which I'm calling matrix mean. Okay. So we have some matrix, and then we have an additional attribute with that matrix that is the mean of that matrix. Okay. And so I call attrv, I define what I want to call this thing, and then I define what it is. Okay. Then when we go attrv matrix mean, we get 3.5, right? It tells us that is now stored with that vector, really, but with that matrix. Okay. And so anything can be stored as an attribute, including potentially other data frames or other matrices or whatever. Okay. Also, anything that you can think of can be stored as an attribute. There are, however, reasons to avoid this, and this is part of why I don't do this very often. One is many operations, as we'll see here in just a second, will strip attributes. Okay. So you do something to it, and then those attributes you had are gone. Okay. The other reason is if you are tying a bunch of stuff to an object and then you're moving it around all over the place, that can be really inefficient, right? So it might be better to just have one function that does something and another function that does a second thing and run them both once, rather than running one function that puts out this thing with this giant matrix with some other giant data frame attached as an attribute, and then you're trying to move that into other functions. Okay. All right. A short example of one case where I did do this recently. So I was working with a database that had multiple years of data, right? And the tables in the database were pretty much the same for each year, but the values, of course, differed in each year. So kids are in grade 3 one year, the next database, they would be in grade 4. So it's the same kids, but they're in grade 4. And now we have a new set of kids who are in grade 3 in that database, et cetera. So we might want to return the data, but store the year that we accessed as an attribute. That way, when you're doing things later down the line, like let's say you're, I don't know, creating a plot, right? You could pull the data, do some processing, and then when you were creating the plot, you could pull the year from the attribute of that thing and put it in the title as part of the plot, right? Or in the caption or whatever. Okay. All right. Oh, so this is just a very quick example. I'll go through this really quick because this isn't that important. But this is like a list that I'm using to mimic a database. This is a little complicated, but basically here's a database, right, that has two tables, and they both have like color and transparency. Okay, so we're going to write a function that grabs one of these tables, and if it's 1920, we'll grab the first one. Otherwise, we'll grab the second one. Okay, so we have this year, and so we're saying to poll if the year is equal to 1920. This is like 2019, 2020, right? Then it's going to pull the first database. Otherwise, it's going to pull the second one. Okay, so if I say pull color data 1920, I get this. If I do 2021, I get this. If I do 2122, I still get this, right? I get the same one, either one of these. The only time I get something different is if I do 1920. All right, so that's cool. Now we're going to build a second function to make that does something with that output. Okay, so we want the function though to depend on the year. So it's going to do one thing if it's 1920, and it's going to do a different thing if it's 2021. Okay, so we need to know the year, and we could build this where we're just building in our function where we're requiring the year be supplied, but that's kind of silly. If we've already done that previously, we should be able to just pass that information through. Okay, so we're going to modify our original function to store the year as an attribute. Okay, so here's our toPoll part. This is just the same as before, but now I say that the attributes of out, I'm going to say give me whatever the attributes of out were before, and give this additional attribute db, which is equal to the year, and the year is just whatever is supplied to the argument up here. Okay, so again, this is pretty complicated for the first day, so if you're not totally following, that's okay. All right, so I say pull color data 1920, I get this data frame, and if I say attributes pull color data 2021, what's the db of that? Then I get 2021. Okay, so it's just going to echo back basically whatever data I pulled. Okay, so now we can build our second function, and we're going to have it do something different depending on the year. All right, so I'm creating this print colors function. Okay, and so the first argument is the color data, which is the thing that we're pulling from the other function, right? And so I have this title where I'm saying colors for, and then I'm pulling the db year from the color data, right? So I'm putting this together as the title. And then I'm just going to put the color data in this color swatch and use mtext to put the title on there. This because it's using base plotting. Okay, so then here when I say pull color data 1920, pass that to print colors, I get this. And notice it says colors for 1920. And if I say pull color data 2021, print colors, I get different colors, but it also says colors for 2021, right? And so that's sort of a neat example of, I think it's kind of neat, of how you can use the information that somebody's supplying in a previous information to basically be passed through to additional functions so that you can use that information there as well. Okay. One more quick example. Many of you have probably fit multi-level models in the past. If not, that's okay. It's not that important. But what I want to point out is that they use this in LME4. Okay, so LME4 fits the model. This is the model that we're fitting, right? And then if I call varchar on M and I get the subject, this right here is the matrix it returns. This is the variance covariance matrix for the subject. Okay, so this is the variance. This is the variance for the intercept, this is the variance for days, and this is the covariance, okay? But right below this, notice we have ATTR STDev, okay? And we have the standard deviations of each of those. And we have ATTR correlations, and we have the correlation matrix for this. So this variance covariance matrix is converted to a correlation matrix down here, okay? So when you're running this model, the only thing that is actually returned is this. Like if I pass this to another function, the only actual values it's going to have are those variance covariance values. But I can, from that, pull the standard deviation values, or I could pull the correlation matrix instead from that object by accessing the attributes. Okay? Does that make sense? So this is a case where you cannot use additional helper functions like coef or like names or dim or whatever. You have to use this ATTR, and it's actually basically giving you the code, but you would call ATTR and then you'd give it this object up here and then say stdev. Okay, and that would give you the standard deviations. Questions on that at all? Okay. All right, matrices versus data frames. Usually we want to work with data frames because we almost always have more than one type of data, right? It's very regular that we have string or factor data, and then we have some numeric data, and we might have some dummy codes, which could be encoded as logical or whatever, okay? However, sometimes matrices are much more efficient, okay? And the reason, especially if you have larger data, and the reason is because really, if you think about it, underneath the hood, rather than having this giant list, which is what a data frame is, with all of these different things, you just have a single vector that has these matrices attributes to it. Okay. So what's cool about this is because underneath the hood, it's actually just a single vector. You can do operations to the entire matrix at once, the same way you would do operations to a single vector. Okay, so here's an example where I'm creating not an overly large matrix, but just a matrix, right? Where I'm getting 100 observations from a random normal distribution with a mean of 200 and a standard deviation of 10. I'm saying give me 10 columns. Okay, so this is like a 10 by 10. Or no, yeah, 10 by 10. Okay, so what's cool about this is I can now just say sum m, and it'll give me the sum of the entire matrix, or mean of m, right? And it's the mean of the entire matrix versus like having to go through all of the columns. There are also efficient functions for computing things by row or by column when you have a matrix, using like row sums or col sums or row means and col means. Okay, you can also do things like this where I'm saying I want to standardize the entire matrix, so I'm saying m, the entire matrix, minus the mean of m, right, which is whatever it was, 200, divided by the standard deviation of m, right? And all of this is going to work, and what we end up back is the entire matrix back, but all transformed all at once, right? Okay, so that's sort of neat. I did also say, though, that I would be wary of storing important information as attributes. And the reason for that is because some operations will strip attributes. So within the tidyverse, it's sort of notorious for stripping row names. Okay, if you have important data that are stored as row names in your data frame, you need to get them into a column if you're working with the tidyverse, or it's going to strip them and you're going to lose that information. Okay, so here's a very quick, easy example. Here's V again, where I have these column names, and then I have these row names, and I also have this matrix mean, okay, which is 3.5. When I call row sums on this, the row names are maintained, but they become actually the names of each element of this vector. Okay, so this is it's actually double of type double, even though they all are integers. So this is a vector of type double, where each element of the vector has a name, and those names are the old row names. But the column names are gone, and the matrix mean value is gone. Okay? So if I look at the attributes of row sums V, you can see we have the names, and that's it. Okay? So we don't have the dimensions either. Everything is gone. All right. More on names. This is maybe getting a little too in the weeds, but just very quickly. If I look at the names of V, so coming back here, this is what V looks like, right? If I look at the names of that, you might expect to get the row names or the column names. Instead, you actually get nothing. Okay? And it's because the names are going to say what are the names of the individual elements inside the vector. Okay? So instead, I can say names of V, letters 1 through 6. And so now we have these things, right? And we also have this attribute for names. Each of these are now associated with these letters, A through F. Okay? You can also name them this way. This is, you probably use, in fact, I basically guarantee you have used vectors this way, where you've said A is equal to 5, B is equal to 7, whatever. What that's doing is it's assigning a name for that element of the vector. Okay? So the second element, 7, is associated with the name B. Okay? There's other ways to do this as well. But this is one of the things that I see all the time, which is people confusing names and call names. Okay? Part of the reason that people confuse it all the time is because in many situations they will both work. Okay? But they're not the same thing. Okay? Call names is what you want for a matrix. Names is actually what you want for a data frame. Okay? And the reason is because a data frame is a list. Okay? Each element of that list is a column. Okay? So as I just said, names is associated with the elements of the vector. Okay? So the elements of the vector, in the case of a data frame, are the columns. Okay? So the names are the column names in a data frame. And this is where it's confusing, is names and column names will both work for data frames, but technically you should probably be using names. Okay? Names and column names will not both work, however, for a matrix. And there you should be using column names, because if you use names, you'll get the individual elements of the matrix. Okay? All right. This is just showing you how to subset with names. So for example, now that we have these names, I could say V, give me the one that's associated with the name E, and it will return it. Okay? So that's often helpful. Okay, how are we doing on time? Oh, we're fine. Okay. All right. Factors. I said we would get back to them, right? We're going to implement our own factor right now. Okay? So we're going to do it a couple of different ways. First, I'm going to do it using the base function factor. Okay, so I call factor here, and I say make this vector a factor. Okay, A, B, C. Okay, and I do it with a string. So then I call type of on FCT, and it says integer. Well, wait a minute. I thought the type of was factor, right? But type of does not tell you the overall type or whatever, like the higher order type. It tells you the atomic vector type. Okay? And so let's look at the attributes of FCT. We have this levels attribute, and we have this class attribute. Okay? Just like we saw before. But if I do str on fact, right, which stands for structure, then you can see it says we have a factor with 3 levels, A, B, C. And then it says the values of this thing are 1, 1, 2, 3. Okay? This is where the integer part is coming in. Okay? The way that factors are implemented is they are integers underneath, and then they have this levels attribute where each level is associated with a specific integer. Okay? So we can do this manually, right? Here I'm creating a thing called int, which is 1, 1, 2, 3, 1, 3. Okay? And then I'm going to assign it some levels. I'm going to say, okay, the attributes for int give me this levels thing, and I'm going to assign them red, green, blue. So 1 is going to be red, 2 is going to be green, and 3 is going to be blue. Okay? Then finally, I have to change the class of int to be a factor. And now when I do int, I get red, red, green, blue, red, blue. Okay? And the levels are red, green, and blue. Does that make sense? Okay, so hopefully what I said earlier about atomic vectors being the atoms of R is starting to make sense here now, right? A matrix is just a vector with a dimension attribute. A factor is just an atomic vector with a levels attribute and a factor class. Okay, everything is sort of built up from these 4 fundamental types. So this can definitely make things tricky. So here I'm, I don't know what I'm doing. Oh yeah, okay. So I'm creating a factor here that's called age, okay? And so the age is going to be baby, meaning 0 to 1, or they're 1-year-old, 2-year-old, 3-year-old, up to 10 years old. Okay, so this is just like randomly taking some values from there. But I'm making it a factor. Okay, if I look at the structure of factor, you can see it's a factor with 11 levels. And those levels are 1, 10, 2, 3, 4, and then it'll go all the way to 9, and then baby. Okay, so if I look at age, it looks like this, which is fine. Nothing wrong with that, right? Here's the levels, 1, 10, 2, 3, up to 9, baby. Okay, but what if we wanted to convert this to numeric? So let's say we wanted to just change baby to be 0, and then keep everything else as it is, but make the whole thing numeric, right? That's a pretty common thing that you have to do, all right? So what I'm doing here is I'm going to say, okay, I'm going to make a data frame out of age, and then I'm going to count age. Okay, so it's giving me the count for each of these, for 1-year-old, for 10-year-old, etc. And then I'm going to create a new variable here where I'm saying age numeric, and I'm just going to call as.numeric on age. Okay, so what happens here is 1 is associated with 1, which is great, but 10 is associated with 2, and all of these are now off by 1, and then baby is associated with 11. Why? Why is baby being associated with 11? Any ideas? It's confusing, right? It's because when I call as.numeric on age, what I'm getting back is the integers, all of the integers associated with those levels. So back here, it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Baby is the 11th level. And so therefore, baby is being converted to 11 when you call as.numeric on a factor. Okay, so what we need to do instead is we need to first call as.character on age. Okay, and then we'll say if else age character is baby, then 0, otherwise as dot numeric age character. Okay, and this as dot numeric on age character is now going to work because we're not dealing with the integers at all anymore. We're now coercing a character vector to a numeric rather than pulling the integers out of a factor. Okay, so here's our age character, and here's our age numeric. And now notice they all now match up, and baby is now 0. Make sense? Okay. Dates are also somewhat similar. Okay, so here I'm just using this base function sys.date, which gives you the date currently from your computer, whatever your computer says, right? And if I call type of on date, I get double back, right? And if I actually look at it, it will look like a character, right? It'll say like 2022, whatever, and it'll look like a character thing, but it's not really. The actual underlying date is double. It's a vector of atomic vector of type double. So I can look at the attributes of date, and we just see, all we see is it has this class date. Okay, so what if I strip that date? I'll take the attributes of date and say null, strip that class altogether. When I look at date, I get 19079. Okay, this is the Unix Epoch. It's the number of days passed since January 1st, 1970. So January 1st, 1970 is just like this point that computer people decided a while ago, like a long time ago, is like the start of time for dates. And so that's 0, and then they go negative from there, and they go positive from there. So if we looked at a date from 1920, it would be negative. Okay. So that's pretty much all I have to say about dates. Dates are complicated. This is just for days. There's also date time, which is even more complicated. All right, but the basic point is that all of this is being handled by this date class. Okay, and that's what's making everything work, and that's why very regularly you can use date vectors for things like an x-axis on your plot, because underneath it's actually numeric, and so it works as a numeric variable. Okay. Okay, classes. I don't want to get too in the weeds on this. This is very complicated, but just looking at these 3 things, I'm using summary on each of them, right? But they're all printing very different things. How? Why? What do you think? Summary does do different things depending on the input, but what specifically do you think it's picking up on? The class. Yeah. So in this case, we have empty cars, which is a data frame class, right? And so summary is going to print, it's going to actually, so this is called classes and methods. Summary is a function, and it has a data frame method. Okay, so it's going to print one way when it encounters a data frame, versus in this case, it's encountering a factor, so it's going to print something different. Okay, and in this case, it's got an LM object, and so it's printing yet something different again. Okay, so here's all of the different classes. We can see that that's how they print. Okay, but all of this is part of what is called S3 methods. Okay, again, I don't want to get too far into this, but basically summary and print and all sorts of other different functions behave differently themselves depending on the class of the object that is supplied to it. Okay. All of a sudden my slides aren't working. So summary for empty cars actually gets passed through to this summary.data.frame function. Okay. So this function is what's actually being called when you call summary on a data frame. For the factor one, summary becomes summary.factor. Okay. And similarly, summary m becomes summary.lm. Okay. So the way that, and we're not going to do this, but just as an FYI, right? The way that methods for these generic functions like summary are defined is with a dot after it and then the class. Okay. So some of you may have seen me in the past comment on your object names, and I have probably said something like, I would encourage you not to use periods in your object names. This is why, right? Because if you said, you know, whatever, table.date, right? It's not clear whether that is just a object that is a table date, or whether that is the table, or whether that's the date function for the table, or date method for the table function. Okay, so don't do that. Okay, that's fine. All right, this has been a lot, right? We got just a little bit more I want to get through, and then we'll finish. Okay. So, missing values. Missing values sort of breed more missingness, and you've probably run into this before. If I say NA is greater than 5, I get NA. That sort of makes sense, right? NA times 7, I get NA, which again, I think kind of makes sense, because how do you multiply a missing value by 7, right? And similarly, how can you tell if a missing value is greater than 5? But what might make less sense is this one. NA is equal to NA. What would you expect that to return? True, right? I'm saying, is an NA value equal to an NA value? It should return true. No, it returns NA. Okay, and the reason, and this is like a little pedantic, I think, but they say, you know, really this is the most accurate because there's no reason to presume that one NA value would be equal to a second NA value. And so the best they can do is say NA in return. Okay. Missing values don't always continue forth though, right? So in this case, I'm saying NA or true. Okay. So because it's or, it doesn't matter whether that other one is true or false, right? Or whatever. Because I have one true and it's an or, I get true in response, right? And similarly here, I have NA3, NA5. I'm saying are any of X greater than 4? And I get true because at least one of them is. And what we're trying to test is the entire vector. And so those NAs don't get passed. Okay. So how do we test for missingness? Looking back at this one, NA3, NA5, we've already seen that this doesn't work. So what do we do instead? Use is.na, right? Is.nax, and then we get true, false, true, false. Okay. Last thing for today, lists. Okay, lists are vectors, but they're not atomic vectors. And each element can be different. So we've already seen this, right? And we've also already seen this. They can also be of different lengths. What I can do here, so I'm just checking the type, it's a list, the attribute's null, but I can use this str, which I use all the time for all sorts of different objects, right? It's a good way to inspect the object and see what's inside of it. And so here we're seeing we have a list of 4. Okay, so the first is character, the second is numeric, it's double, the third is integer, and the fourth is logical. Okay, and then it shows us this is length 3, this is length 5, this is length 2, this is length 4, and then it shows us the first couple of values of them. So it's a quick way to do that. Okay, I've mentioned a couple of times that data frames are lists, right? However, they are a special type of list where every element of the list is of the same length. Okay, that's how we get that rectangular structure. If one of the vectors of the list is a different length, then we can't coerce it to be a data frame. We can't convert it to a data frame. Okay, but as long as they're all the same length, then it can be. So here I just have a list, right? LDF, where A, B, C, and D are all different types, but they're all of length 2, every one of them, right? So I can look at LDF here, and this just looks like my standard list output. But over here, I can say data.frame on LDF, and now it looks just like a normal data frame. Okay, and that works because the list has the same length. But notice A, this is what I was talking about before, right? A, B, C, D, those are the names of the elements of the list. The first element is called A, and it has the values red and blue. The second element is called B, and it has these values. Okay, when I convert that to a list, the names of each element become the column names. Okay, but technically names is probably more correct if you're trying to pull them out, but it doesn't really matter that much. Okay, so lists are super flexible, super helpful, as we've seen already. Okay, but they do become very complicated to work with when they're nested in particular. Okay, so when we need to pull stuff out of them, it's not always as easy. Okay, so here is an example where I have an atomic vector here, x, which is just a equals 3, b equals 5, and c equals 7. So it's a numeric vector. I think it actually will be double because I didn't put the L's. But it has these names associated with it. Okay. Then I have a list where the first element of the list is just x. It's exactly that. Okay. The second one is x2, and it's 2 x's. X, then x again. So they're just stapled together. And then x3 is itself a list where we have vect, which is x, squared, which is x squared, and cubed, which is x cubed. Okay. All right. This should have been down here. That's bad style. Okay. So when we're subsetting a list, there's multiple different ways we can do it. Okay. We can use single brackets, or we can use double brackets, or we can use the dollar sign. All right. If I use the single bracket, what I'm going to get back is a list every time. Okay. So this is super important and super complicated until you get your head around it, and then it's really natural. But it takes a while to get your head to be for this to be natural. So single bracket will always return a list. Double bracket, like we have down here, will actually return the contents of the list. Okay, so L1 returns X, a list with it's a list of length 1 with one element, X, that has this in it. If I use L double bracket 1, it's no longer a list. I get back the actual vector itself. Okay, so if I say type of L single bracket 1, I get list. If I do type of L double bracket 1, I get double. Okay, and then from there we could subset more if we wanted to. So here I'm pulling C with using single brackets. So notice anytime you're subsetting a vector, an atomic vector, you use single brackets. You never use double brackets for atomic vectors. You only use double brackets for lists, and you only use double brackets when you're trying to pull the contents of the list instead of subsetting the list elements. Okay, so another sort of illustration that Hadley put together is you have this pepper shaker that has packets of pepper in it, right? And this is like X. This actually happened because he was at a hotel and this is how they gave him the pepper. So x1 single bracket, right, would give you the first pepper packet, right? X double bracket 1 is going to give you the actual pepper packet. And then X double bracket 1, or it should be probably single bracket 1, unless this was a list, if you're considering that a list. That gets you the actual pepper back. Okay, I actually think this one's probably a little bit better, thinking about it like a train, right? And so for the train, you have these cars, right? And if I said X1, it's going to give me back just the first car with the train still, right? So it's going to give me all of this. But if I do double bracket 1, then I get the actual contents from the cargo thing. Okay. So again, if I do X1, 2, I get a list back that has just the first and the second elements of that list. If I do X single bracket -2, I get the first and the third, right? And I could even do X1, 1, and I would get the same element repeated, right? And if I did X0, I would get just the list back, which can sometimes be helpful. Okay, so we'll end up working with that a lot, the difference between the single bracket and the double bracket. Okay, so that's something we'll have to become more and more familiar with, but it's a really important topic, especially as you start to work with lists more. Okay, the other thing is that can make lists much easier to work with is if they are named. Okay, so in this case, our list does have names, and anytime they are named, you can use the $sign. And that's exactly why the $sign works with data frames, because every column is named, and so you can use the $sign to pull that list element. Okay, so from L, if I wanted to grab X2, I could say L $sign X2, and that gives me just that vector back. L $sign X3, that actually returns me a list because that third element, X3, was a list, right? That had vect and squared and cubed. And again, each of these are named, okay? So you can actually continue on and say, I just want one of these, and you can go L $sign X3, $sign squared, right? So you can just keep building up this $sign like this, and that'll give you just that one back. However, if I wanted to pull one of these elements out of here, these are named too. So you might think I could just go $sign again, give myself another one, but that doesn't work because notice it says the $sign operator is invalid for atomic vectors. Okay, so this is exactly the type of error message that you may have gotten previously, and it makes no sense. And now with all of this background, hopefully that makes some sense, right? You're trying to subset an atomic vector, and you're using the $sign, and R is telling you you can't use the $sign when you're subsetting an atomic vector. Okay? But we could do something like this. Okay, so you can subset with the brackets with a name for atomic vectors. Okay? You can also subset in different ways. So you can subset using a logical vector or by just using indices. Okay, just be careful with your brackets, because in this case, when I say true, false, true, I'm saying give me the first and third element of the list. So I need a list back to store that, right? And so I need to use single brackets. Same here. If I do this, this is not going to work. It actually doesn't make any sense, right? It's trying to pull the first and the third from the first. Like it doesn't make any sense, right? You're trying to pull the contents out with the double brackets. So you need to give it just a single integer usually, or whatever. Okay. All right. Last thing, you can also subset in multiple dimensions. So generally we have two-dimensional data, right? Rows and columns. But you can actually do more. Okay. So in this case, let's say I wanted to select the entire fourth column. I could just say all rows, fourth column. okay, with the single bracket. Or the fourth row, give me the fourth row and all columns. Okay, so blank means all. Okay. These are basically equivalent. So I'm saying give me the fourth row and the columns with the name MPG and HP. Okay. And this one, I'm saying give me the entire fourth row, then subset that column to give me only, or that vector to give me only the ones named MPG and HP. Okay. This is another part. I know we're all tired. This has been a lot of me lecturing today. Hopefully the rest of the days won't be quite this much. But this is like a super key difference between tables and data frames. By default, with a regular data frame, if you say give me one column, it's going to return basically the contents of that column. So you will no longer have a data frame. Okay, so when I say empty cars, all rows for the fourth column, it's going to just give me an atomic vector in return. Okay, if instead I want to actually keep the data frame, I just want the fourth column, then I would specify another comma here and say drop equals false. Okay, and so that drop equals false is going to say keep the data frame structure and just give me the fourth column. All right. This is the exact opposite for tables. Okay, so tables take the opinion that generally you're going to want the data frame back. And so if you, for empty cars tibble, so notice I just converted it to a tibble here. If I say give me the fourth column, I get a data frame back in return. Okay, and if I want it to not be, then I would say drop equals true. This can be a headache when you're programming because you have to have checks for, okay, give me the fourth column, but then I want it to either be a data frame or I want it to be a vector. So when you're programming, it's very important to be specific like this. Specify whether you want it to drop the data frame attribute or not, right? So if you want to then add another column onto that, you're going to not want to drop it. But if you want to do something like compute the mean of it, then you do want to drop it, right? Okay, there's also, you can have more than 2 dimensions. I do this very rarely, so I'm not going to spend much time on it, but here's a 2 by 3 by 2. So basically 2 matrices that are kind of stacked on top of each other. And then from there, you could select, you know, just the second matrix or the first column of each matrix. All right. And again, this sort of thing can be very, very efficient, but sometimes it's hard to wrap your head around. Okay. Last thing on lists. Lists are super common return types for functions. So for example, here, I'm fitting a linear model, right, to this object M. When I call str structure on M, it says it's a list of length 12. Okay, the first element of the list is the coefficients, that's of length 2. And notice that has its own attributes, which are names, intercept, and horsepower. Okay, then we have the residuals, which is of length 32. Okay, and that also has a name attribute. Then we have effects of length 32. Down here, we have assign, which is an integer of length 2. QR, which is a list of 5. QR here, which is a matrix. Okay, so the list is super flexible, and often you're going to want to dig into these lists to get the stuff out of it that you want. Okay, so that's it for today. I know that was a ton, and I apologize for so much lecturing from me. Hopefully the rest of the classes won't be quite that much. Next class we'll talk about loops with base R, and we will have our first lab. So again, if you can try to make it into class, that would be great. If not, that's okay. All right. Thanks, everybody.